It is great to see you back on Statistics Made Easy. In our previous sessions, we explored how we can prepare our dataset for our analysis. And now we are ready to run our first descriptive statistics. For this purpose, I open the data do file that I've created for this session called Descriptive Statistics. Remember, you can find all the do files and data in the video description below. The do file is set up in a very similar manner to our previous do file. Everything that's green is my comments and annotations so that you can easily follow along and see what each line of code is doing. I begin by first clearing Stata's memory by highlighting all these rows here and hitting Control D on my keyboard, and then I set more off so that no output is omitted. Next, I define the directory where my data is located using the cd command for current directory and load my data set. Now, this data set is already in the Stata format. If you haven't got that yet, check out my video on data preparation where I show how we get to this Stata formatted data set with all the variables that we need. Our first step is to understand a little bit more about the variance structure of my data. And the summarize command is a useful first step. For example, if I want to learn more about the mean value, standard deviation, minimum, maximum of my variables ice cream and temperature, I run the summarize command, and in the output window, I now get the corresponding results. For instance, for ice cream, I have 123 observations, a mean value of 26.3, a standard deviation of 27.4, a minimum of 0, and a maximum of 121. I may equally be interested in understanding the frequency of certain observations in my data, and the variable child is a binary indicator that contains information about whether my customer is an adult or a child. If I use the tabulate command, I get the frequency statistics showing that 51 adults are in my data set and that 72 children are present. And in the column next to that, I also see the corresponding percentages. If I want to see the correlation between two variables, I can use the core command. For example, core ice cream and temperature will give me the correlation between these two variables, which in this case is 0.89, which is a very high correlation. Anything exceeding 60% or 0.60 would be considered a very strong correlation. Alternatively, I can also run a partial correlation using the mkcorr command, in this case between ice cream and temperature, taking into account the effect of income. But as you see, I get an error message here in the output window, no observations in red. Now, the reason why I get this error is because I'm trying to run a descriptive analysis using a string variable. Remember that income is a string variable which contains text because we have certain values that are coded as NA. However, in our data preparation, we also created a corresponding numerical variable which is called income underscore num. So if I use this variable instead, I now get the corresponding result of my partial correlation analysis here in the output window. So just make sure whenever you run these sorts of analyses that all your variables are in the correct format. And it usually doesn't make sense to run any correlation between, for example, categorical variables, and it doesn't work for string variables at all. Next, I want to create a new descriptive statistics tables, namely the correlation matrix, including information about the mean value, for example, of my variables. There is a user-written command that is really helpful in achieving this, but you first need to install it. And this can be done using the sst install command followed by the command name, which in this case is mkcorr. There's a ton of user-written commands that facilitate your analysis. So first of all, I install this new command. And once that is done, make sure you have a working internet connection when you do so. We can use that code. For example, here I use this mkcorr command followed by all the variables that I'm interested in including in my correlation matrix. increase, ice cream, temperature, child, income, city, train station, etc. Note here that I do not use the categorical variable here, but the binary variables that I created previously. So always make sure when you have a categorical variable that you convert those into binary variables first for your correlation matrix. In addition, I also specify a few options here. For example, that I want to have 2 decimal points for my variables, that I want to have the statistical significance, and that the file should be replaced in case it already exists. Also note that I use 3 forward slashes here between the lines. And 3 forward slashes means that I'm using a line break. Stata will interpret it as if everything was in the same line. Ice cream followed by temperature followed by child, income numerical, etc. This can be helpful if you want to add further annotations or keep a better overview of very long commands like this one. Now I run this code, which now opens or gives me in my current directory a file called core, which contains the correlation matrix. It's not beautifully formatted, but if you copy that, for example, in an Excel spreadsheet, it will look probably like you want it to look with, for example, the labels here of my variables. Some are not labeled, but most of them are labeled. And when you copy that, for example, into an Excel spreadsheet, make sure that you set the formatting in Excel to text only and not values, because otherwise Excel might interpret any values that are in parentheses as a minus value, and that could look a little weird in your output. Now we can move on to our next section here, which is very similar to the previous command, but using the inbuilt alternative for Stata. But it only runs if you're using Stata 18 or higher. The command basically creates the same sort of table in a Word file, and I've created here some annotations for you. For example, what type of values are collected here for my variables. So I here collect the mean value, the standard deviation, the minimum and maximum as before. I define the labels. For example, here I can set the number of decimal points after my numbers. For example, here I have 2 decimal points. If I want to use 1, I would put 9.1 F in this parenthesis. And then once I have added all my labels to my variables, I can then publish this whole table to a Microsoft Word file. I'm going to run this code, and I think you can check it out for yourself. The only thing you really need to adapt in your case is the variable names here, that they correspond to the variables that you want to use, but the rest should be very, very similar in your case. Running this code will then create a new file in my current directory, which is called descriptive statistics. And if I open this, I see here the descriptive statistics. For example, the mean values, the standard deviations, the minimum, maximum, etc., and also the pairwise correlation for all my variables. So this can also be a very useful tool for my descriptive statistics. And now finally, I want to create a scatter plot in Stata. And a scatter plot can help me visualize the correlation between 2 variables. So it is a very handy add-on to a standard correlation matrix. And the command is in principle very simple. It is scatter ice cream temperature, and I could run this code directly, for example, my command line, and I will get this scatter plot, which looks fine. But I can also set a few more options in Stata. For example, I can add a title to the plot, which I do here. I can define how the plot region, so the background, for example, of my file should look like. And finally, I also want to save my file using the graph export command, and I can then specify the file format. In this case, I use a TIFF format, but you can also use JPEG or also vector representation, which is less pixelated. Now, running this command will give me the scatter plot with my labels. It looks very similar, but a few more options that will help you also change the layout of this whole file. And it also now appears in my directory as the scatter plot. Thank you very much for watching this introduction to descriptive statistics, and I look forward to seeing you in our next video session.